Run your hand under cold water for long enough and it starts to hurt. Not feel cold, not feel numb. Hurt the exact same way a hot stove hurts. And that's not your imagination. That's your skin telling you the truth about something it was never able to hide. Your body cannot actually feel temperature. It never could. This is the story of why cold can burn you, why frostbite and fire leave the same scar, and why the difference between ice and flame to your own nervous system is smaller than you think. Here's what you think is happening when you touch something. You think your skin measures how hot or how cold it is, like a thermometer. Warm things read warm, cold things read cold, and your brain just reports the number back to you. That's the obvious answer. It's also completely wrong. Your skin has no thermometer in it. Not one. There is no cell anywhere in your body whose job is to tell you the temperature of the thing you're touching. What you actually have is far stranger, and once you understand it, ice water and boiling water stop being opposites and start looking like the same event, running in two directions. To see it, forget the word temperature for a moment and think about heat as a thing that moves. Heat always flows from hot to cold, always. It's one of the most reliable rules in all of physics. A warm cup sitting in a cold room doesn't stay warm. The heat quietly leaks out of it into the air until the cup and the room are exactly the same. Your body is that warm cup. It runs at about 37 degrees Celsius, and every second of your life, it is leaking heat into everything cooler around it. The air, your chair, the floor, the cup in your hand. Now, here's the part they never taught you. The sensors buried in your skin do not measure temperature. They measure that leak. They measure the direction and the speed that heat is moving across your skin. Touch something warmer than you and heat floods into your hand. The sensors fire heat coming in. Your brain reads that signal and calls it hot. Touch something colder than you and heat rushes out of your hand. The sensors fire, heat leaving fast. Your brain reads that signal and calls it cold. So hot and cold were never two different things. They are the same measurement, heat flow, pointing in two opposite directions. Your skin isn't a thermometer. It's a current meter dropped into a river, and all it can tell you is how fast the water is moving and which way. Now, watch what happens when that river moves too fast. When you touch something very cold, heat doesn't just leave your hand, it stampedes out. The colder the object, the wider the gap, the faster your warmth drains away into it. And here's what most people never realize. Your skin has a second set of alarms completely separate from the hot and cold sensors. These are your pain sensors, and they don't care which direction heat is moving. They don't have a setting for hot or a setting for cold. They only ask one question over and over: is my tissue being damaged right now, yes or no? Rip too much heat out of a patch of skin too quickly and the cells inside it start to fail. Their chemistry stalls, their membranes stiffen, and the pain alarm goes off. That alarm has no word for cold. It only knows damage. So it sends the exact same signal it would send for a red hot stove, because as far as your nervous system is concerned, it is the same event. That deep, aching, please take my hand out of the water feeling, that is not cold. That is your skin being injured, screaming with the only voice it has. Push it a little further and the disguise falls apart completely. Grab a bare metal railing that's been sitting outside in freezing weather, and for a split second, it can genuinely feel hot. People flinch and pull back like they touched a stove. Children have pressed their tongues to frozen flagpoles and torn the skin trying to get free. Because at that temperature, the metal doesn't just chill you, it rips heat out of living tissue fast enough to kill it. We even have a name for the wound cold leaves behind. We call it an ice burn, and that's not a figure of speech. Put an ice burn and a heat burn under a microscope, side by side, and they are disturbingly hard to tell apart. The same ruptured cells, the same blistering, the same dead and peeling skin. So let's put that in perspective. Frostbite is not the opposite of a burn. Frostbite is a burn, same blisters, same scars. The only thing that's different is which way the heat was flowing at the moment your cells died. Fire pours heat into you until your proteins cook. Ice drags heat out of you until your cells freeze and shatter. Two opposite causes, one identical injury, one identical scream. And if you still don't believe your skin is this easy to fool, scientists built a device that proves it. It's called the thermal grill. Picture a set of metal bars laid side by side like a tiny fence you rest your hand on. Every other bar is gently warm. The bars in between are gently cool. Not one of them is anywhere near hot enough or cold enough to hurt you, but lay your palm flat across all of them at once. else, and something impossible happens. You feel a sudden, searing burn. Your hand jerks away from bars that could never actually harm it. There's no heat there. There's no damage. Nothing is burning you, but your brain receives the warm signal and the cool signal at the very same moment, gets hopelessly confused, and does the one thing a confused nervous system does when it can't tell what's happening to it. It assumes the worst, and it fires pain. A burn out of nothing, conjured by two harmless temperatures sitting next to each other. That is how thin the line really is. Now take that same fragile system and drop the whole body into cold water at once. Fall into a cold lake, and before you can think a single thought, your body does something you cannot stop. You gasp, a huge, involuntary, lung-filling gasp. Your heart slams. Your breathing tears out of control. This is cold shock, and it has drowned strong swimmers in seconds. Not because they were weak, and not because the water was deep, but because that first gasp came while their face was still underwater. Your skin registered heat leaving your body faster than it had ever felt in your life, and it hit the panic button for your entire nervous system. It didn't check the depth. It didn't check whether you could swim. It just felt the river of heat rushing out of you all at once, and it screamed loud enough to override your own lungs. That is how seriously your body takes heat loss. It will hijack your breathing to try and save you from it. And if you want the final proof that your skin is reading a signal and not a temperature, it's already in your mouth. Bite a mint, breathe in, your mouth floods with cold. A clean, icy cold, like you just swallowed winter. But nothing in your mouth got colder, not by a single degree. A thermometer sitting on your tongue wouldn't budge. What happened is that menthol, the chemical in mint, reaches into your skin and flips the exact same cold sensor that real cold would flip. It picks the lock. Your brain gets a signal marked cold, with no cold anywhere in sight, and believes it completely. That's the whole secret, sitting on your tongue. Your body was never sensing temperature, it was only ever reading a switch. And anything that flips that switch, ice, wind, or a leaf, becomes cold. Which brings us to the strangest part of all. Because your skin measures heat flow and not temperature, it can be fooled, badly and constantly, every single day. Step out of a warm bath into a mild room and you shiver like it's winter, because the film of water on your skin pulls heat off you far faster than dry air ever could. Same room, same temperature, wildly different feeling. Set a metal spoon and a wooden spoon side by side on the same table, in the same room, overnight. Then touch each one. The metal will feel noticeably colder, but it isn't. They are the exact same temperature. You could check with a real thermometer and they'd match perfectly. The metal only feels colder because it pulls heat out of your fingertip faster, so your skin panics louder and calls that panic cold. You have trusted that feeling your entire life. That feels cold, so it must be cold. But your skin was never once reporting temperature. It was reporting how fast it was losing heat and calling that cold. Your whole certainty about hot and cold is built on a sensor that has never measured either one. And this isn't just a curious quirk. It quietly runs your life. It's why frostbite has to be treated like a burn, warmed slowly, never rubbed, never blasted with hot water, because if you thaw those wounded cells too fast, you damage them a second time. It's why a fever can leave you shivering under 3 blankets while your body is running hotter than normal. Your heat flow sensors are reading the cooling surface of your skin, not the furnace at your core. It's why the weather report gives you a wind chill, a second colder number, because wind strips heat off you faster, and your skin will believe that faster number over the real one every time. And it's why cold water can burn you is not a trick of words. It's the literal physical truth. The burn was never about temperature. It was always about heat leaving your body faster than your body could survive. So the next time cold water starts to hurt, remember what that pain actually is. It isn't your skin telling you that it's cold. It's your skin telling you that it's losing and using the only word it was ever given for that. Fire and ice were never opposites. They just moved the same river in 2 directions.